In this video, I will show you some applications of quadratic functions. And one application in particular that we will look at involves projectile motion. Projectile motion is when something is shot upward or thrown upward with some initial force, and the quadratic function will model the path or the height of that object. And also free-falling objects is another thing that is modeled by a quadratic function. But dealing with projectile motion, there is a formula that we can use to model that, and the formula that determines the height of a projectile is S of t. So S in physics and calculus typically stands for the position of an object. So S of t, so this is going to be the height of the object in t seconds, is given by the formula negative 16t squared plus v sub 0 t plus s sub 0. The negative 16 deals with a coefficient that models gravity. T is the time in seconds. S sub 0 is the initial height of the object in feet. And v sub 0 is the initial velocity, and that is measured in feet per seconds. An example that will involve that formula is this. A rock is projected upward from ground level at an initial velocity of 90 feet per second. How high will the rock be after 1 second? What is the maximum height the rock reaches? And when will the rock reach the ground? The first thing we want to do is to write a formula that represents the height of the rock. And that's given by this projectile motion formula. So we have S of t is equal to negative 16t squared plus our initial velocity times t plus our initial height. The initial velocity will be told to you, and in this case it is 90 feet per second. So we are going to have negative 16t squared plus 90t plus our initial height. Because the rock is projected from ground level, the height is 0 feet above ground level, so we'll have a height of 0. So we can simplify this to write S of t equals negative 16t squared plus 90t. Now that we have a model, we can use it to find the answers to these questions. Part A is to find the height after 1 second. So we know the time, we need to find the height. We're going to replace the t with 1 in this model to get S of 1 equals negative 16 times 1 squared plus 90 times 1. Simplifying this expression gives us negative 16 times 1 plus 90, which is negative 16 plus 90, or 74. So after 1 second, the rock is 74 feet above the ground. Part B is to find the maximum height the rock reaches. If you recall, one of the features of a quadratic function and its graph is that when a parabola is opening downward, which we have in this case because of the negative value of a, the function reaches a maximum point, and that point occurs at the vertex of the parabola. And so anytime you have a quadratic application and it says to find the maximum or minimum, your goal is to find the vertex. Remember that when we have a quadratic function, the vertex can be found using a formula, and the x value of the vertex is negative b over 2a. Because our x variable or input is t, we will have that t is equal to negative b divided by 2a. Therefore, the time when the rock will reach the maximum height is the opposite of b, which is 90, divided by 2 times a, which is negative 16. So this is negative 90 divided by negative 32. And when we perform that calculation, we get 2.8125. Now this is the x value, or the t value, which is seconds. This value tells us when, or how many seconds it takes for the rock to get its maximum height. It does not tell us the actual height. To find the height, we have to replace t with 2.8125 in the formula for the height. So s of 2.8125 is negative 16 times that value squared plus 90 times 2.8125. And when you determine that value on the calculator, you should get 126.5625. Therefore, the maximum height the rock reaches is 126.6 feet. Understand that the y value of the vertex is the height. The x value of the vertex is the time it takes to reach the height. Part C asks us to find when will the rock reach the ground. So the rock on the ground will be at a height of 0. In this case, we want to solve the equation then when the height, s of t, is equal to 0. That is, we know the height. Now we need to find the time it takes to get to that. We set negative 16t squared plus 90t equal to 0. This is a quadratic equation that we need to solve by factoring or one of those other methods, a quadratic formula, completing the square. I would just use factoring in this case, noticing that they have a common factor of a 2, and there's also a t common, and because of the coefficient being negative that leads, we would actually factor out a negative 2t. So that's going to leave 8t. And then minus, 45 equals 0. Then we set each of those to 0, so we have negative 2t equals 0, or 8t minus 45 equals 0. Dividing by negative 2, we get t is equal to 0, or 8t equals 45. So t will be, 45 divided by 8. So t is really 5.625. So when will the rock reach the ground? Well, of course, it started on the ground. That's our initial value of 0. It will reach the ground in 5.625 seconds.